All right. Hello, everyone. This is our presentation for our semester project that we're currently working on. We're going to give you a bit of a status update, tell you what we're doing and what we're going to be doing. So our team name is AHHI, which is just the first initials of all of our names. So we got Austin LaMontagne, I'm Thompson, Chen, and Issei Sawano. So for our presentation, we'll give you our current project stage, what we're going to be doing with the CR16 architecture, and what we're going to do to make it cool. And at the end, we're gonna give an update as to the challenges that we faced and kind of how we plan on getting through that, or how we have gotten through those. So our current project stage. We've completed the ALU, so we went through and made all the instructions so that they would do their proper thing with the registers. We took muxes from something we had already created so that we could implement them in the data path. With our register file, we completed that and then hooked it up to the muxes in the ALU so that we could actually get results from that. And we are implementing the controller so that we can tie that all together. All right, so our project, as you might have been able to tell, is the Pong game. So you got two paddles on each side and a little ball of pixels that goes back and forth, and you just try to stop it from going past your paddle. Originally, the game was programmed just for hardware, but we're going to be programming it for software so that we can use it with our FPGA. And a little fun fact is that Nolan Bushnell, who is a Utah alumni, helped design the game back in the 1970s. And he's also the co-founder of Atari. So that's a cool little thing. So in addition to just the baseline CR16 architecture, there's a few things that we are considering adding to that to make it applicable to our project.
So for what we're adding to the CR16 architecture, we're obviously implementing Pong, and we want to have two separate controllers because it's two-player. And so we're probably going to be have both those controllers hooked up to the GPIO on the board, which is on the in this image, far left side of the board, and just communicating through that, which I'll break down more in the next slide. And then for additions to CR16 architecture, we might add some specific instructions that have to do with moving the paddle and updating the positions of the paddles themselves, such as like a dedicated instruction maybe to incrementing or decrementing the position of the paddles, as well as something potentially to compare the position of the paddle to the ball and see if there's any collisions for that. So as far as IO requirements go, we're gonna be displaying the game through VGA onto a monitor. So updating that with the positions, as well as, like I said before, we're gonna be using a controller. And specifically, we'd want to use, or our idea is to use an NES controller or two NES controllers. And as shown in the top right, is the pinout for the NES controllers. And there are 7 different pins, so in total there would be 14 that we'd have to connect through GPIO, and the data would just come through that as potentially a bit stream, and then we'd have that and maybe a custom module to update the positions of the paddles in the ball. And then something we'd also potentially add, but we're not certain if we will or not, depending on if we get there, would be audio. And so this would just be something such as impact sounds of the paddle hitting the ball, or someone scoring a point. And so just some sort of indicator to make it more interactive. And so as far as the Pong implementation goes, we would probably, or we want to code it in C, and then we would theoretically convert that to CR16 assembly using some sort of program or something. And so we want to make sure that our implementation, potentially the ALU, matches up nicely with standard CR16 assembly, just so everything matches up nicely and we can implement our game properly. And so as far as implementing it in code goes, we would have to keep track of object positions, have that be the paddles and the balls, as well as collisions between the balls and the paddles, misses, so if the ball ever reaches the edge of the screen, and then if someone scores, depending on which side of the screen, updating the score for that individual player. Okay, and as far as our challenges that we faced, I'm going to pass this off to Hong and Issei to talk about those.
So for challenge, we put 4 points and how to take input from control and update registers and memories. We will figure out VGA and how to display the game.
Being able to follow directions and having creative freedom means we would have to find ways to implement systems. Direct implementations for the AOU instructions for the CR16 architecture would probably be the hardest part.
Sweet. And thanks for watching.
Cheers. Good luck, everyone.
Peace.